Hello, welcome everybody to another webinar. My name is Uzair Khan. I'm a member of the NCache marketing team. Here with me today is one of my colleagues and our solutions architect, Ron Hussain. Today we have a very exciting topic. We're going to be talking about using .NET caching in EF Core to scale EF Core apps to extreme performance. Entity Framework Core, or EF Core, is the new cross-platform and lightweight object relational mapping engine from Microsoft for .NET that eliminates the need for most of the data access code that developers otherwise write. Similar to .NET Core, EF Core is also cross-platform, meaning you can use it on Windows, Linux, Mac, and it's getting very popular within the developer community. In this webinar, Ron is going to talk about the performance and scalability requirements in EF Core applications, and we'll demonstrate different strategies to cache reference and transactional data using EF Core extension methods. Now, before I hand it over to Ron, I just want to highlight, if you have any questions, feel free to input them into the question box on the right-hand side, and that way I'll be able to jump in and ask those questions from Ron. All right, without further ado, take it away, Ron.
Very good, very good. Thanks, Uzair. Hi, everybody. My name is Ron, and I will be your presenter as far as technical details are concerned. And as Uzair has suggested, today's topic is about Entity Framework Core, how to scale out your application to achieve extreme performance as well as linear growth in request handling capacity. So you can scale out your Entity Framework Core application using NCache extension methods. So we have lined up some options that you can utilize, different scenarios that I will paint, and then based on those I will introduce NCache extension methods as well as object caching features that you can use within a typical Entity Framework Core application in your environment. I believe everybody can see my screen. If I can get a quick confirmation around if you guys can see our screens. Audio looks fine as well, so please give us a confirmation. Very good. I've got few, so I think we're good. All right, so let's quickly get started. First of all, I would talk about Entity Framework and Entity Framework Core in general. I'm pretty sure everybody knows about EF and EF Core, but just for the sake of completeness, to build some introductory details, Entity Framework is an ORM that you can use for .NET, and with EF Core you can also use it for .NET as well as for .NET Core. Entity Framework simplifies your database programming. You can work on conceptual object model, so you don't have to work with data model directly, and it simplifies overall data access programming. You don't need to write persistent code yourself. It could generate a lot of interaction between your object layer within your application to the data model that you have. And using database access, which is generated by Entity Framework Core. It's very popular for your .NET and .NET Core applications. You can use it in any kind of application, it could be a web application, it could be a typical server application. .NET or .NET Core web services, IoT use case, or any other server application can utilize this because of its popularity and also because of its ease of use. It's very easy to set up, and you can get started with it. Entity Framework Core is a new variant. That's the new direction Microsoft is taking. It's first of all open source. It's cross-platform, so you can run an application which is using .NET Core or .NET. It can run on Windows with .NET, and with .NET Core it can run on Windows as well as on Linux environments. And similarly, Entity Framework Core follows the suit, right? So it actually allows you to run on Windows as well as on Linux environments if that's a requirement. And then it's very lightweight and modular in nature, which essentially means that you don't have to go through all components within Entity Framework that you used to have. With EF Core, you can work with the component that you need. You can only get NuGet package for that, and based on that, you can incrementally build complexity within your application. So if you need to manage complex scenarios within your application, for that matter. And on top of it, it's super fast because of .NET Core. There is a specific focus on performance side as well. So Entity Framework Core has been designed on the same guidelines where performance is one of the key factors that you would be able to achieve. So Here is a architectural diagram for Entity Framework Core. I've found an Entity Framework diagram which still applies for a lot of things still apply on Entity Framework Core architecture as well. This is from MSDN. With EF Core, you have ADO.NET data provider. I'll be using SQL Server as a data source example. And then you have Entity Client Data Reader, which builds up command trees, data access, scenario. And then you have object services, and on the application side, you either work with entity SQL query or link to queries, link to entities. So again, you work with object model, and behind the scenes, the Entity Framework Core takes care of all the other details. There's a command that you run to generate, your mapping and model at runtime. So conceptual model, EDMX, all of those, mapping files, they've gotten rid of those within Entity Framework Core. So it's very easy to set up again. Again, it's modular, so you can introduce NuGet packages and you can build a very simple Entity Framework Core application in a matter of minutes. Right, so next I would talk about scalability. That's another concept that I wanted to highlight. Why do you need caching in an application which is using Entity Framework Core? First of all, there's a concept of scalability. That is a very good feature within an application where you are able to achieve high application performance, and that too under peak loads, right? So if you're able to have low latency and lowest latency possible, and you maintain that low latency under low user load, let's say 5 to 10 users, and if you have an application architecture designed in such a way that you can manage the same kind of low latency under huge amount of user request load, then that application would categorize as a very scalable application. And linear scalability is a further associated concept where you can add more and more servers, and you can distribute your load, and by distributing load on multiple servers, more servers would actually increase the request handling capacity, and that increase should grow in a linear fashion. So if you have an application which is growing its capacity as you add more servers, and that too in a linear increase manner, that would be categorized as a linearly scalable application. So typically applications which are high transaction in nature, such as ASP.NET or ASP.NET Core web apps, web services, IoT, big data applications, or any other general .NET or .NET Core applications which are using Entity Framework Core, they demand high scalability, right? So they need high transactional load handling capacity within their architecture. So where exactly is the problem? Why do you need a caching system to overcome that problem? You can always create a web form and an app form where Entity Framework EF Core application can scale out linearly on itself by creating a web form or an app form. You can put a load balancer in front. So that's not the main point of concern. Your application tier can always scale out. That's how Entity Framework Core and any typical .NET or .NET Core applications are designed, where you can route requests to multiple servers and still be able to use them in combination to one another. Main problem is your data storage bottleneck. Typically, if it's a relational database, that's the example we're using. Databases are usually one single source for all your data storage. They're very good for storage. That's something that they're best at. But when it comes to handling extreme amount of request loads, for example, you have a lot of transactional and reference data load coming in from your applications, database is not designed to handle that increased amount of request load. It would work well under low user loads, but when it starts to consume capacity on the CPU side, on the memory side, and then there's a DBMS tunnel where all the requests are being routed, chances are that your data storage becomes a scalability bottleneck. It would give you performance degradation where it would queue requests which are being generated at runtime. So there's no way you can add another database server. First of all, it's expensive to start off, and then there's no way you can have two servers being used in combination to one another. So it would not add up to the performance value. It would degrade your performance, and that would impact your end user experience as well. And that can in turn impact your business as well, because if your applications are slow in performance, a lot of users would not like that sluggish or slow behavior from your application. So applications need low latency and high throughput all the times, and maintaining high throughput comes with a toll of losing performance, and that's what databases tend to see, where they simply slow down your applications, or they tend to choke down completely in most cases as well. Right. So in this section, we'll talk about how to tackle this. The solution is very simple. You can use distributed caching system by NCache. It's very fast because it's in memory. It's very scalable because it's not just single source. You can have as many servers as you need to added in a cache cluster, and those servers in a cache cluster work in combination to one another. You can distribute your data, and then you can distribute the request handling load. And by adding more servers, you achieve more scalability out of the system as well. And it's not a replacement of your conventional relational databases. You use a distributed cache within your EF core application in combination to a database. So you either cache most readily accessed data, your reference data, or you cache some of your transactional data as well. And I'll talk about how to handle different caching scenarios, caching strategies that you can utilize within your application. Please let me know if there are any questions. These are introductory slides about the introduction. Why do you need caching and how it's going to help? Here's a deployment architecture that would further clarify a few things why it's better option in comparison to relational databases. First of all, distributed cache sits in between your application and the database tier. And by saying in between, it's essentially your application would first use cache. If it finds data here, it should return. If it doesn't find data here, it should only then go to the backend database, right? So in a logical placing, it sits in between your application and the database. As far as deployment is concerned, you can have your application deployed on VMs, on physical boxes, on-prem or in cloud. NCache is supported on Microsoft Azure as well as on AWS in the form of a pre-configured image, or any other cloud can use our installer, which could be downloaded from our website, and then you can get started by installation, which is very easy to set up. NCache can be on its own respective tier, separate dedicated servers for NCache, or it can run on the same boxes. If you have boxes where your application is deployed, you can deploy NCache on the same tier as well. We recommend having separate boxes, and you can add 2 to 3 servers to start off, and then you can add more and more servers based on your request handling requirements. If you need to handle, let's say, 10,000 user and their associated request load, you can run some tests and you can see how many servers you need. In general, based on a recent test, we were able to achieve 2 million requests per second with just 4 to 5 NCache servers, right? So you can see how many servers you need in order to handle your application load requirements. Only prereq for NCache is either .NET or .NET Core. It runs on Windows Nano, as well as on Linux servers. Similarly, your applications can be on the Windows platform or on the Linux platform. And there are some powerful database synchronization features as well. Like I said earlier on, it's not a replacement of your conventional databases. It uses your database, it gets used alongside your database, right? So some data would be cached, but all of your data would always exist in your permanent store, which is your relational database. And I'll talk about how to go about caching in a bit. Please let me know if there are any questions. We're just building out some basic details about the caching and its introduction. Here are some common use cases, general use cases for distributed cache, and most prominent is your app data caching. We have Entity Framework Core here. Is there a question?
Yeah, Ron, we've got a question come up. Does NCache support EF Core only in the Enterprise Edition? What are the options for open source and the Professional Edition?
Okay, very good. This is something that I would cover right here. But just to answer this question, yes, Entity Framework Core extension methods, and that's what we have our main focus on today. It's only an Enterprise Edition feature, so you would have to have Enterprise Edition in order to use these extension methods. But if you guys plan on using direct NCache APIs, then it's not specific to any edition of NCache. Our direct NCache APIs, these are regular object caching APIs where you connect to cache and add and fetch or retrieve data from NCache using NCache API calls. That's something that you can use within open source, within professional, as well as within enterprise. Extension methods are easier to use in comparison, where we have done a lot of work for you, and I have some examples which I will show you once we come to this portion. I hope that answers your question, and it will be further clarified once we move on to that section. All right, so first use case, which is our most common use case, is our app data caching use case. In this, you typically cache data which belongs in the database. Motivation here is that you save expensive database trips as much as possible. And benefits that you get are high performance for your data retrieval, because databases are slow in comparison to in-memory access. So it's in memory, so it's super fast. And then you have multiple servers which are hosting and serving your requests from your application. So you get more scalability, more throughput out of the system, and while maintaining low latency. That's given for distributed cache. And in most cases, it's highly available and reliable as well, based on the topology that you've chosen, unlike databases, which may not be replicated across other servers. With app data caching, you can cache almost anything. You can use direct APIs. You can cache your domain objects, collections, data sets, single items, results, whichever data that you want to cache, and you need that data again, you should consider using our object caching. And with Entity Framework Core, again, you can use direct APIs or extension methods, which I will show you. Then another use case for NCache is it's ASP.NET and ASP.NET Core specific caching. We have our session caching. Session caching in ASP.NET Core is through iDistribute Cache as well as through our NCache session provider as well. So that's the second option. And then we have SignalR backplane. That's another option that you can utilize. If you have a SignalR application, you can use NCache as a backplane. This is again a no code change option. And then we have response caching, view state and output caching. So these are all the features which are specific for ASP.NET. And in addition to this, you can also use app data caching within your web applications if needed. And then we have powerful pub/sub messaging and continuous query events, or I would say pub/sub messaging and events. You can use NCache as your messaging platform, where multiple applications are connected, and those applications can talk to one another using our pub/sub messaging. An application can publish messages to NCache, which acts as a communication channel. It has a concept of topics, and then the subscriber applications can receive that message if they're connected to that topic. So they can coordinate with one another, sharing data as well as custom messages if needed. And we can build social media systems. You can have chat system, you can have leaderboard, you can have use it in any kind of industry as needed, where you need to have different components of your application coordinating with one another. Microservices is another use case where you need to have serverless microservices applications interact with one another, and they can use NCache for their communication needs. And then we also have continuous query events, regular events where your data gets added, updated, or removed. Instead of application sending events, NCache can send events to your applications based on data changes. And this could be on all items, or on selective items, or based on the continuous query, where you map a data set in NCache, and NCache only sends events for that specified data set. There's a fourth use case as well. We have full text search feature, where you can, it's very common in e-commerce applications. With NCache, we've implemented Lucene.NET API. So if you're interested in full text search feature, NCache comes fully equipped with that as well. All right, so next I will talk about, I've lined up some sample applications. If there are any questions, please let me know. I believe this is some basic details around the use case for caching and why you need it. Let's talk about how you would use caching in a typical Entity Framework Core application. So first of all, I have this application, sample application, lined up right here. It's one of the samples which come installed with NCache as well. So if you go to C program files NCache, these samples are available right here. .NET and .NET Core samples are separately placed. So I would go ahead with .NET Core and Entity Framework. We have EF Core sample right here. So that's the sample I'm using. I've changed it a little bit to demonstrate some of the scenarios which I'm planning to present in this webinar. Otherwise, it gets the basic job done for your POC. Right, so this is the sample, and next thing I would do is I would log on to our demo environment, and I would get started by creating a cache cluster for you, so that you actually use a cache cluster and take it from there. Right, so for cache creation, we have our web management tool up and running. I'm going to quickly create one. So let's go ahead and add a clustered cache. Let's name it demo cache. I'm going to append a few integers, demo cache 111. You can, by the way, keep JSON or binary format as far as serialization is concerned. Oops. There you go. So you can have binary or JSON serialization format. I'm going to go ahead with binary because that's the default option. There are 4 caching topologies that you can choose from, and we have other webinars such as NCache architecture, which are specifically targeted for explaining NCache architecture. So I'm going to go ahead with partition replica cache because this works very well for reads, very well for writes, and it's super scalable for read and write request capacity if you keep adding more servers. And it comes equipped with replica as well, so there's no downtime or data loss for your application as well. So I will keep everything simple, default, async replication between active partition and its backup. So I'm going to choose that. It's faster. Size of cache cluster, and here I specify servers which are going to host my cache cluster. Like I said, I'm going to quickly create a cache because our main focus is Entry Framework Core. Otherwise, in our regular webinars, NCache architecture or scaling NCache, your applications with NCache, those webinars talk about all these features in great detail. So in this particular webinar, I'm just going to go ahead and create a cache quickly. Right. So I would specify default port TCP/IP, and I would start and auto start this cache so that it starts up automatically when your server gets rebooted. So that's pretty much it. As far as cache configurations are concerned, you only need to follow this visit, and that would create a cache on multiple servers. It's not, I think it started as well. I would open statistics window, and then I would open NCache monitor window, which is another tool which comes installed with NCache. Currently there's no activity, but I can go ahead and run a stress testing tool application. It's called test stress tool, and that would simulate some dummy activity, dummy load on my cache cluster, just to verify that everything has been configured properly. Right, so you can see about 1,000 to 1,500 requests per second by server 1 as well as by server 2. So in total, it's handling about 3,000 requests per second. And you can review latency. We have very minimal average microsecond per cache operation latency. I think it's somewhere between somewhere around 4 to 5 microseconds. So this graph would update and unit would go down once we add some more load. Let's actually go ahead and do that. Right, so I have another instance running up just to show you that now it should show the increased value right here. There you go. So we have about, previously it was handling about 1,500 requests per second by each server. Now it's somewhere between 2,000 to 3,000 requests per second by each server. And you can see average microsecond per cache operation is somewhere around 50 to 60 microsecond per operation. That's a huge performance gain, considering your applications are not being maxed out or servers are not being maxed out at all. So you can expect sub-millisecond or microsecond responses from your applications when using NCache. So our environment is configured, everything is set up. I think we're good to go. Let me stop these tests, and let's go ahead and create review our sample application, which talks about caching scenarios. Please let me know if there are any questions at this point.
Hey Ron, we had a couple questions come up. One of them is, and this is from before, in terms of PubSub, have you guys done some sort of performance benchmarking against Redis?
Okay, we have done our benchmarks, but those are NCache performance numbers. We have recently, concluded those tests, and based on those test results, and that includes our regular features as well as our PubSub and any other features such as SQL searching or link queries, we were able to achieve over 2 million requests per second with 4 to 5 NCache servers, right? And we saw a linearly increasing trend By adding more servers, you can further stretch those throughput numbers, and we were able to achieve less than 10 microsecond latency for individual operations. With right kind of hardware, you can even get better results in your own lab as well. We use Microsoft Azure as an environment, and we're in a process of publishing those benchmarks on our website as well. As far as comparison with Redis is concerned, we as a company policy, we do not publish performance numbers against other products. We have feature level comparison, which is available on our website, and we encourage our customers to perform their own tests and come up with a fair conclusion in comparison to other products. I can share a comparison with Redis as far as feature related details are concerned, but for performance, I would recommend that you test it within your environment.
And we have one more on top of that, if that's all right. It's on messages. Are the messages persisted? How reliable are messages?
Okay, typically PubSub is a loosely coupled communication platform, right? So you don't want publishers to know about subscribers and vice versa. And similarly, it's not guaranteed about message delivery. That's the thought process behind PubSub. So by default, your messages are not going to be persisted. If you send a message as soon as those are delivered, they would be removed from the communication channel. But if you guys are interested in persistence, that's a feature that you can turn on, right? So NCache allows you to persist messages for we call them durable events, right? So you can have durable events where you can specify a time period, and you can even have a persistence attached to those messages as well. So that's something that you should turn on additionally. So that's supported with NCache.
Thanks, Ron. I'll let you get back to it.
Very good. Thanks, Uzar. All right. So let's talk about, first of all, how to go about caching within Entity Framework Core. What EF Core entities to cache? You have two options typically. You may have a single entity, or you have a query result, which is an entity collection, right? Single entity returned, or or it could be a collection. Single entity is stored as is. Collection can be stored as a single item, or each collection item can be added individually in the cache as well. And let's talk about how to go about this. Direct NCache APIs, there are two approaches. First of all, you can use NCache APIs directly, right? So that's something which you can use in open source, enterprise, or professional as well. And then we have Entity Framework Core extension methods, which I will spend some time on. Direct APIs, here's a detail of direct APIs. Let me show you this from here. Right, so typically this is your get customer method. If you're using direct APIs, chances are that you may have a customer ID. So first of all, you need to construct a cache key, right? So that's something that you need to do as a must, because within NCache, everything is stored in a key value pair. Key is your string key to identify an object, and object part is the actual value, actual property that you want to add in the cache, actual data that you want to cache for your application. So I have come up with this key organization where I have customer as a keyword, and then customer ID, and then I provide a runtime parameter which is passed on to me, right? So that would identify this particular customer right here with customer ID something uniquely, right? So that it would uniquely allow you to identify those customers. And then you call cache.get to retrieve items from the cache, right? So first of all, if you're using caching, you need to make sure that you have the key constructed, and then you first check data to be available in the cache by calling cache.get. And this cache handle is something that is returned when you initialize the cache, right? So I'm using this cache right here, and cache.initialize cache. It allows you to initialize the cache and get connected to it. If you find the items in the cache, which means customer was not null, you simply return from here. You save expensive trips to the database, and that's the main motivation of using the caching system, where NCache would have your data, so you'd save your expensive trips to the backend database. You don't have to go to the database. But since it's the first time starting up this application, so in that case, cache would not have the data. So in that case, you would execute Entity Framework Core link inside Entity Framework Core. It would return either a single item or a collection. It's a single item scenario. And then you call cache.insert to actually add this for next time usage. and return the customer as well. So next time you would always find this data in the cache as long as it's not being changed or not being synchronized with the data. So that's our single use entity, direct APIs. In case of collections, direct APIs are very similar. We have customers by city. Customer city is a runtime parameter. We'll construct a list of customers and try to fetch that collection list from NCache, cache.get, get a list of customers. If that's not null, return from here. If it's null, we need to retrieve it from the backend database and also add it in the cache for next time usage. So that's how it is. And if you want to store these customer items individually, you can also iterate through this cust list and individually call cache.insert by providing unique keys for each collection item as well. So that's another option that you can utilize. But you see, you have to first construct a key, get the item from the cache. If it's there, do the null handling, and then if it's not there, you get it from the database, execute the data logic, and then also add it. So that's something that you have to do with direct NCache APIs. It's the most common use case for any typical database caching. For app data caching, this is what you would normally do. But there's another approach that is through our extension methods, and that's the main highlight. You can cache entire collection as one item, or again cache each collection item separately, but through extension methods. Here is our first extension method that I want to show you. All right, so it's called from cache, but it does a lot of automation for you, right? It works in such a way that first of all, it allows you to construct some caching options, right? So you first of all create caching options, and one of the attributes that I'm introducing at this point is store as. So NCache would allow you to choose whether a collection is needed to be stored as a single item, as individual items, collection items. Let's say there were 10 items in a collection, so those would be added as 10 separate items in NCache, or you want to store it as a collection, which is right here, right? So that's the second option. In this case, it would be stored as one item in the cache. So I'm using separate entities. So if I run this code right here, I have an extension method which says from cache, and it's, if I show you the definition of this, it's coming from NCache Apache Sau.ncache.entity framework core. That's the main namespace. And if I come right here and show you the NuGet packages, under installed, we have Apache Sau.ncache.ef core NuGet package. So that's the NuGet package that you need to introduce, and after that you can get started with these extension methods. First of all, it's an out reference cache key. So cache key is going to be generated by NCache and given to you. So that's the flexibility, and then it just takes the options as a parameter, right? So it does a lot of automation, and behind the scenes it's doing a lot of work for you. From cache works in such a way that it would automatically check data in the cache first. That's the behavior. If it finds, it doesn't go to the database. But if it's not in the cache, then it would go to the database as a rule and get the query executed, result set retrieved, and then add it in the cache using this cache key being populated, and then these caching options set up to that item. So if you compare it with this one, you don't have to construct the cache key. You don't have to check null handling or getting from the cache yourself. You don't have to insert it in the cache. You just need to use this extension method. So that makes a lot of things automated, and it's very simplified programming model for your applications as well. And same case where you would like to store it as a collection, you simply provide the caching options to be collection, and in this case you have a list of customers that you would return. So you just run the query and then again call from cache. So that completes our first extension method and introduction to it. Please let me know if there are any questions around it.
Hey Ron, we got a couple more questions come up. One of them is NCache single-threaded or not? And does NCache suffer from data size cache issues where a mixture of large or small KBPs results in potential high latency?
All right, first of all, NCache is purely multi-threaded application on the client side as well as on the server side. We have a request response models which are completely multi-threaded in its nature, so you can have all those requests being handled in parallel, unlike other products which are based on single-threaded model. And we have a lot of features which are, on top of it, you get a lot of feature set support as well. And second question, if as far as data size limit is concerned, first of all, cache, overall accumulated size of a cache is something that's configurable. So if you plan on adding, huge amount of items, size of those items can, increase the memory utilization on servers, but you can restrict how much memory you want to give to a cache, and then you can increase that memory at runtime. As far as individual item size is concerned, where you have a mixture of lower size items as well as bigger size items, anything which is permitted by .NET and based on the serialization buffers that you have. Typically, we recommend having bigger items broken down into smaller ones by storing them as separate entities, as individual items. But as far as limit is concerned, we do not enforce any size limits on the client end. We recommend that you should break down your bigger objects into smaller. That's more performant. And if you even if you have bigger objects, you can use our compression feature. So that's another feature that you can turn on. We recently worked with one of our customers which were dealing with the same kind of issue, where they had bigger item size and their requests were being timed out. We simply turned on compression, and that completely resolved that issue within the environment. They did not get any timeouts after that. So there is no limit. There are features, and we generally recommend that you should bring your bigger objects to smaller size, store them individually, and take advantage of distributed caching. I hope that answers the question. Please let me know if there are more questions.
Just one more to add, if that's all right. Can you say how the cache key is constructed here? Would this differ from when the query is changed?
Absolutely. It actually, I can show you one example once I would run the sample application, but it would change based on the query. So it's not going to be, same query executed again would point to the same cache key. But if the query changes, the cache key would also be with the change information. I would show you some cache keys once we move on to our hands-on portion. But to answer your question, these are going to be different for different queries.
All right, thanks, Ron. I'll get back to it.
Very good. Next, I would talk about reference and transactional data. This is the main segment. You would be dealing with applications which have a lot of reads, data with a lot of reads, then writes, and then there could be application scenarios where we have reads as well as writes, right? So for example, lookup data, products, employees, which does not change that frequently, but it's not static data. It's something that changes, but frequency of change is not that great. And entire data should exist in the cache in this particular scenario. I'll explain why. And you should expire this after some hours or days. That's how to keep cache fresh. That's another segment. Then we have transactional data. I will talk about how to handle transactional data caching. It's dynamically created, orders, accounts, those are examples. It changes very frequently, and typically historically transactional data was not preferred for caching, because it was supposed to change and it was supposed to go away from your application while your user is active is only needed at that point. But based on our experience, we highly recommend that you enable caching for transactional data as well, because while you're not changing it, that data is still active. You may read it a lot of times, and if you have millions of users logged in, those would result into millions of requests for that data going back to the database. And if it's cached, and even it could be 2 to 3 requests while it's going to change, it's still going to be beneficial from a performance standpoint. So highly recommend that you should consider caching some of your transactional, if not all. All right, how to handle reference data caching in EF Core. I have 2-step process for this. You can load entire data in the cache. That's a must-have. So all of your reference data should be loaded in the cache. That's what we recommend as a must. Why? Because you don't want to go to the database at all, right? You should go ahead and start loading all of your reference data in NCache. And we have an extension method that would take care of this right away. And then only use cache and avoid database trips. Step 2 is always cache as separate entities. That's another tip that I would give you, that you should not cache all products or any other, all products as a collection, right? It could be thousands of products or millions of products. But storing them individually would allow you to fetch subset of the data at a later stage, right? So for example, you load all products, but at a later point from cache, you only need discontinued products. So if you have stored them individually in the cache, let's say 60,000 products, that's the example that I would show you, you can only find the ones that you need at that point. So you don't need to deal with the entire product data set. And again, saving expensive trips to the database. So we have extension method called load into the cache. That's next I'm going to show you, and I'm going to show you a working example of this as well. Now load into the cache, first of all, caching options should set as store as separate entities, and then you should run a query which should load all products, and then you should call load into cache and then provide the options. And again, it would just create cache keys for all of those individually automatically, and it would keep loading all those items in the cache. And then you can run link queries like this, and this link query is against NCache. It's not using any extension method. It's calling product in database products where product are discontinued, and we have from cache only. It's not going to the database at all. It's getting it from NCache directly. If you have reference data, you should first of all load separate entities, use load into cache to load all products in NCache. Once you've done that, you don't have to go to the database. Then you use from cache only instead of from cache. First extension method was from cache, which checks in the cache and then goes to the database if it's not in the cache. But load into cache would load all products, and then from cache only would ensure that it only talks to the cache with an assumption all data is loaded in the cache. Let me run this code so that you see this in action. I have a cache which is configured right here for this test, and I'm going to show you statistics. I've been playing around with it. 60,000 products are loaded, so let me just go ahead and clear the contents. Right, so let's review statistics. Where is my cache? There you go. Right, so it's 0 items, and then I will go ahead and run this. Excuse me. It would just cache a single item, then a collection, all the code examples that I've shown you, but I would like to show you how load into cache works, and based on that I've put a breakpoint there as well. There you go. So first two examples were loading a single item and then loading a collection, the initial code that I had shown you. And then this right here is actually loading all products to show you reference data scenario. First of all, it's storing as separate entities, and it's setting up some priorities, some dependency, it's elaborate in terms of that, and then it's going to go ahead and load all products, getting it from the database. And I highly recommend that you keep running load into cache after some intervals so that you have data retrieved from the database. And load into cache always works against database. It's always going to go to the database, and whatever you have in the database, it's bound to execute against database and fetch that data back to NCache, and then use from cache only afterwards.
Wanted to bring up something quickly, Ron. Situational question: if you store as separate entities, but the where clause matches 60,000 products, is this a single round trip or 60,000 round trips?
Okay, that's a very good question. For example, let it load, and I will use this as an example. The queries afterwards are based on our own extension of link, right? So that is a reader-based approach. So there is a chunk that you can specify. So you expect that your products are going to deal with 60,000 products, and that's the result set that you're expecting. So instead of fetching them at once, you can use our execute reader. So behind the scenes, it would fetch a chunk of products as you use them, right? So it's not going to create 60,000 products as a result set and bring all of them at once, because that's expensive. You used to have that, but over a period of time, we have changed that implementation, and now we have reader-based approach on NCache queries as well. And here is an example of this. If I run, now we have all products loaded, 60,000 products, and this query will not go to the database because it's going using from cache only, which only works against cache with an assumption that all products are already in the cache. If I run this, it would fetch those products and it would find me all the discontinued products, for example 8 out of those. It's a small result set, but if it was 50,000 or 60,000 products coming from cache, this would bring a chunk of products based on the reader approach that I talked about. I hope that answers your question. Please let me know if there are more questions around this. Right, so I'm going to go ahead and print these products. It's just getting those products, iterating through them. There you go. So we have all those products which are discontinued loaded. So that's how you deal with reference data. First of all, you store them individually, separately, load into cache using this extension method, load into cache, which always executes against database. It does not have cache as a priority. It would always execute against database and then fetch everything back to NCache and then use from cache only. That's how simple it is. Transactional data, you can load only working set. It's for result set caching, right? I personally recommend that if you're interested in, customers by a city orders based on a product, you should have some kind of result set caching, and that's what you should do. You should store them as a collection or separate entities based on the size of the result set. If a collection is not that big in size, let's say it's dealing with 100 or 200 items at max, store them as a collection. But if there are multiple products, multiple orders, or customers information, that would categorize as a transactional data. Store them as separate entities so that you can get subset out of that and you can maximize your use of caching. And use case for this is very simple. Again, you simply store it as a collection or use from cache. You don't use from cache only because you would like to go to the database if it's not in the cache. So far we've introduced 3 extension methods: from cache, which works with cache and database automatically, and not in the cache, you would get it from the database. Load into cache would always execute against database, fetch objects and bring it to cache, and from cache only always executes against cache, and that's the only true source of data. It would not go to the database. So I hope that clarifies a lot of things. Please let me know if there are any questions. Next segment is based on how to keep cache fresh in an entity framework core, and that's another important concept that you guys need to understand when dealing with 2 different sources. You have caching enabled, you have backend database, which is your main data source, persistent data store, and then you have caching, which also has a copy of data. So how to ensure that cache is fresh in comparison to database? So let's spend some time here. First of all, you should, since you have entire data set in the cache, what if there is a change in the database, right? So you need to expire data from the cache, and for that we recommend that you use expiration and then automatic reloading of data. It could be an option 1. So strategy 1 is that you use expiration but with auto reload, so that each time data gets expired, it gets automatically reloaded in the cache as well. And for that we have this setup right here. Load all products. Let me just show you this from here. Right, so first of all, you store them as separate entities because that's the reference data use case. You load them as all products, and then you set up some kind of expiration, and then options.set resync provider. There should be a reloading provider, and then setup is sync enabled to true. So auto reloading, so that it's automatically reloaded in the cache in case it expires, right? So these are the 2 properties, along with, if you set resync provider name, that would automatically set the auto reload flag to true. And then you need a resync provider right here, which is a sample implementation is right here that I'm showing. There you go. You need to implement our read through handler, right? Read through provider. Initialize your data source, dispose it at the end, and then you load from source allows you to get the key, and based on that key you construct a SQL command and fetch the items from the database. And I've given a sample implementation here where we construct a SQL query from the cache key that we have, right? So that key, and this sample implementation is available on GitHub as well. So it will work in such a way that your items which are loaded in the cache, if I run load into cache one more time, they would have expiration attached. So they would be expired after 5 to 10 hours, whichever is the expiration period. And after that, this provider would kick in and it would call load from source using our rethrough handler automatically, and updated data is brought into NCache. Right, so your cache would automatically be fresh after items are expired from it. Second approach, which I personally recommend, is don't use expiration, manually reload by calling load into cache. And that's something which is very simple, that you should come up with this load into cache method. If I show you one more time, keep calling this method after some intervals and don't use any expiration. Let's get rid of these. So you know that this is going to be, the reference data is only valid for, let's say, 1 hour, 2 hours, 5 days, week, month. Based on that, keep repeating this load all products. This should be called after some intervals, right? So that's the idea, that you should reload data manually based on intelligent guess made on the expiry interval, right? So you should come up with a working time set, after which you should automatically call load all products, so that it automatically gets the data from the backend database and your reference data is kept fresh. So I'm going to reiterate these. So there are two options. If you're using expiration, data is going to be removed from the cache, so you would end up with partial set, so you need auto reload as a must. But if you don't use expiration, you would have all the data in the cache all the times for reference data, and then you can manually reloading that data after certain intervals. I hope that clarifies. Next, I would talk about keeping cache fresh for transactional data. And that's very simple. You should always use short expiration without auto reloading, because that's again a short-lived data which may be valid only for 5 to 10 minutes, and you should use from cache, so that if it's not in the cache, you should always get it from the backend database. And here is an example of it, where we have customer orders. Store them as a collection or individual items. It's entirely up to you. Short expiry if needed, or don't use any expiry, or use the expiry and then don't use any auto reload for that matter, so that it's retrieved from the database as soon as it gets expired. I personally recommend using configurable expiration, or come up with the expiration that you know for sure that that's a working set time for this data set, so that after that it would not be needed, so it should expire automatically, and then at that point you would enforce a database access and you automatically get it from the backend database. So we've covered how to handle reference data as well as transactional data. Then we've also covered how to keep cache fresh for reference as well as transactional data. Please let me know if there are any questions. Otherwise, I'm going to touch a few more concepts of caching, and then we'll conclude the presentation.
Hi, Ron.
Yep.
Just a question to throw at you. What is a more recommended approach? Direct NCache APIs or extension methods?
Okay, very good. Like I said, both options are there. We've given examples of direct APIs as well as extension methods. First of all, if it could be based on addition. If you have open source and professional, direct APIs is the only option, right? So you would go with direct APIs. So there is no extension method for those scenarios. But between choosing this for enterprise edition, you have both options. Direct APIs would allow you to get more control yourself. You would be constructing cache keys, you would be getting data yourself. So it's going to have a lot more control, but you have to write a lot more code in comparison as well. Whereas our extension methods are automated, a lot of programming is done by us. We've automatically cover a lot of scenarios for you. So it's going to be ease of use with extension methods, simplified database programming with cache programming with extension methods. So that's the comparison that you can draw. If you have developers which can implement this themselves, and if you would like to take control of things, you can choose direct APIs. And if you want simplified approach, then I would recommend that you use extension methods. I hope that answers your question. Please let me know if there are more questions. Few more concepts and then I'll conclude.
Oh,
yeah.
one more to add to it. Can you get when a cache is created, or like so can help decide whether or not you need to keep or you need to refresh?
Yes, I believe if you're talking about cache entry being created, yes, there is a creation date time attached to individual items. So you can keep track of that and then you can reload, but it could just be based on your own experience, right? For example, product catalogs. You may be dealing with some items which are on sale, right? So those items may be available on sale for, let's say, 2 to 3 days, right? So you can come up with a flexible time period for expiration, and based on that, you should manually reload data as needed. But there is a creation date time attached to cache items. So if you want to use that value, you can very well do so.
Thanks, Ron. I'll let you continue now.
Very good. Okay, so few other things that you may encounter with caching, handling relationships in cache for EF Core. Again, it's very simple. Include is supported. So if you have region with database regions, and then you get region.territories alongside them, right? So you can call from cache and would store regions separately and territories separately, and they would formulate a relationship between region and territories. So if I show you get region with territories, if that's an example right here, right, so this region details includes, and then we're using from cache, so we'll store regions as well as region territories separately, separate items, and then we'll construct a key-based dependency. If regions go through a change, territories are also going to be invalidated, and vice versa. So that's how you would handle one-to-one or one-to-many relationships. Aggregate operations are also supported, so you can run these extension methods with deferred first or default from cache. It can be on, based on deferred count from cache, so it would store them as result set, right? So this is, it doesn't matter if you store them as collection or single items, because this is just result of aggregate operations. So that's another possibility with our entity framework. So then towards the end, I would like to talk about some architectural details about distributed caching, why you should consider it. It's highly available, it's super reliable with replication. It's a peer-to-peer architectured cache. There's no single point of failure. You can add or remove any servers at runtime, and clients have connection failover support built into it, so it's highly available and super reliable with 100% uptime. It comes with many caching topologies: client cache, WAN replication, partition, and partition replica. And I can specifically talk about architectural details if there are any questions. Otherwise, at this point, this concludes our presentation. And Uzair, if we have 1 to 2 minutes, I would like to give a quick recap of this. So we talked about how are we doing on the time?
We're looking at about 2 to 3 minutes.
Very good. That's all what I need. Very good. So guys, in this webinar, we talked about caching options, direct APIs, entity framework core extension methods. So we have options of choosing between these. We were more focused on entity framework core extension methods because that's what we would like to project. It's easier to use. How to tackle reference and transactional data. So we talked about approaches of loading entire data for reference data and then using separate entities approach, and then use cache only for all the data that you have in the cache. For transactional data, we recommend only caching result set, and then use from cache extension method so that you can go to the database if it's not in the cache. And then for keeping cache fresh, we talked about that you should use expiration with auto reload for reference data, or don't use expiration but manually reload after certain intervals. And for transactional data, make sure you use expiration, right? That should be short expiration but without auto reload, so you can go back to the database and refresh your cache on next usage. So I hope, I know it's a lot of information, but please let me know if there are any questions. I hope it was helpful. I would hand it over to Zara at this point if there are no questions.
I got one more question I can throw at you. When the cache is down, does it go to DB?
Well, if the cache is down, if you're using extension methods, it's automatically going to go to the database. But for direct APIs, it would raise an error that your cache is down at this point. So you have to choose between, you have to understand what you're using. If you're using direct APIs, it would raise an error that cache is down at the moment. But like I said, cache has multiple servers in it. It would be a very rare scenario if all those servers have been down at the same time. If one of the servers go down, that's no downtime. Surviving nodes would ensure that there's no interruption as far as your application is concerned. But if its entire cache which is going down, for direct APIs you would get an error, but for extension method it would seamlessly go to the database.
Okay, are you okay with one more question, Ron?
Yes, I can take one. Yeah.
There was a previous question on whether or not wouldn't cache invalidate be a better approach for transactional data versus a time?
Cache invalidate be a better approach. I need some more details on cache invalidate. I believe this is more on the database dependencies, right? If that's the question, we do support it. So I've shown a time-based approach because that was easier to demonstrate. But if you notice, one second, if you notice our example right here, this options, you can also set up some dependencies as part of that. Let me show you this real quick and then we can conclude. Right, so if you notice, we have create dependency. If you set this to true, I think you guys are referring towards some kind of mechanism where database changes and then there's a invalidation based on that trigger. So we do support it. But in this webinar, I wanted to highlight a simple approach where it was a time based. So there are many options you can invalidate items. It could be based on database change, and that should trigger an invalidation. It could be time based. It could be based on your custom business requirements. So you can also use custom dependency for that matter. If you can elaborate your question, and I can share some more details, but if that's what you're referring, we do have that as a feature set as well. Any other questions?
I think that's it for now.
Very good. Very good.
All right. Thank you very much, Ron. Guys, if there are any more questions that we weren't able to get to or that you want to bring up even after this webinar, feel free to type them in the questions window and I'll be able to get those answered for you. You can always reach us at support@alachisoft.com if you have any technical queries. You can also reach us at sales@alachisoft.com. If you'd like to take a look at the product, you can go to alachisoft.com and download NCache Enterprise for a 60-day free trial. If you have any questions, let us know. Otherwise, thank you so much for all of you who attended today, and we look forward to seeing you in our next webinar.
Very good. Thank you, everybody. Thanks, Uzair.
Thank you.